Get on board. The race to Mars is on, and now is the time to begin. While SpaceX leads much of the conversation, it's not alone. China is advancing bold plans of its own, adding pressure to the growing competition. In response, Musk and Shotwell have made stunning announcements. A proposed Mars timeline and the first major contract tied to that vision. So, how far has Starship really come? And how close are we to liftoff toward the Red Planet? We are now in the second half of 2025, and the window for launching a mission to Mars is fast approaching. It's SpaceX that continues to take the boldest first strides in this long-awaited Mars program. Recently, Gwynne Shotwell, president and COO of SpaceX, made an exciting announcement on the social media platform X. She wrote, "Get on board. We are going to Mars." SpaceX is now offering Starship services to the Red Planet. We're excited to work with the Italian Space Agency on its first-of-its-kind agreement. More to come. This marks a monumental moment in SpaceX's journey to Mars. The first official customer has now signed on. According to updates from the Italian Space Agency, the partnership involves sending scientific payloads on a Starship flight. These payloads are designed to gather crucial scientific data during the mission. In other words, the first Starship journey to Mars will carry much more than just a robotic crew. Alongside Optimus, the humanoid robot SpaceX is developing, the mission will carry meaningful experiments that will help lay the groundwork for future missions. Shotwell's phrase "more to come" hints that this is only the beginning. More international collaborations and customer payloads are likely to be announced soon, signaling growing interest and global investment in the mission. With each new partnership, the Starship Mars timeline becomes more attractive, more credible, and more exciting. Speaking of the timeline, Musk has been increasingly vocal about the schedule for reaching Mars, offering updates through tweets, presentations, and interviews. While some of these projections may seem optimistic, they also provide a rare look into the short-term, mid-term, and long-term planning that SpaceX is putting into the Mars program. In terms of short-term goals, Musk recently reiterated an earlier idea, giving it more precision than ever before. He stated that there is a slight chance of Starship flight to Mars crewed by Optimus in November or December next year. That time frame targets the final 2 months of 2026, which is now less than a year and a half away. Though Musk himself admits the likelihood is small, the fact that a specific date has been mentioned shows clear intent and strategic focus. If such a mission succeeds, it would represent a giant leap in Mars exploration. Until now, efforts have been limited to small rovers and helicopters, but Starship, with its immense cargo capacity and reusability, would completely redefine what is possible. The presence of a humanoid robot like Optimus would add even more value, allowing for sophisticated tasks on the Martian surface in environments too harsh or risky for early human crews. Yet, this ambitious schedule comes with challenges. There is a vast amount of work that still needs to be done to make the mission feasible in such a short period. Musk himself emphasized this when he noted that a lot needs to go right for the 2026 mission to happen. Moving on to the midterm goals, Musk has set a more realistic and likely target. He said, "More likely first flight without humans in around 3.5 years and the next flight with humans in about 5.5 years. This timeline places the first uncrewed mission to Mars sometime around early 2029 and the first crewed mission around 2031. If that schedule holds, it would allow SpaceX to gradually ramp up operations, gathering valuable data and perfecting systems before sending astronauts. This milestone also intersects with a critical moment in global space competition. China, for instance, is rapidly advancing its own Mars plans. The Tianwen-3 mission aims to retrieve samples from Mars with a launch window in 2028 and a return to Earth around 2031. As with its lunar sample return efforts, China views Mars sample collection as a key step toward eventual human missions and surface bases. Meanwhile, NASA's own Mars sample return program has encountered significant delays and budget overruns, with projected costs now exceeding $11 billion and its timeline pushed to around 2040. The program faces increasing scrutiny and is at risk of being scaled back or even cancelled outright without major revisions. This puts even more weight on the shoulders of SpaceX. If Starship can demonstrate a successful Mars mission by late 2028 or early 2029, it would not only outpace NASA's current schedule, but also put the US ahead of China in this next era of interplanetary exploration. Launching earlier than China's Tianwen-3 would be a powerful signal of leadership and capability in space. It would also offer a significant advantage in establishing early infrastructure, securing resources, and staking a claim in the new frontier. In the long term, these early missions could be remembered as the first foundational steps in building a permanent human presence on Mars. From transporting essential cargo to carrying humans across millions of kilometers, Starship could make possible what once seemed like pure science fiction. So now, with international partners joining in, timelines becoming more defined, and real hardware progressing every day, the countdown to Mars is no longer hypothetical. It is active. It is happening. And the world is watching. We often focus on Starship's timeline, but its physical capabilities are equally, if not more, important. The size and scale of this revolutionary vehicle are already setting it apart in the Mars race. Even though it may not reach full payload capacity in its earliest missions, Starship still offers the potential to transport significantly more cargo than any other launch system currently in development, including China's. Practical terms, this means Starship could return far more Martian samples than any other mission. Larger sample volumes translate into more comprehensive research, enabling scientists to understand the red planet with greater precision. And while a direct sample return by Starship is still a major hurdle, SpaceX has other options on the table. The spacecraft could also carry dedicated return vehicles or advanced sample collection systems, supporting those missions indirectly while maximizing every launch opportunity. This approach is especially promising in the near term, where rapid development and time-sensitive launches are key. Moreover, this phase of the Starship Mars program will coincide with new international partnerships. Italy has already signed on as SpaceX's first Mars customer, marking a historic collaboration. And as Gwen Shotwell teased, more to come. This suggests that a growing number of countries and research organizations may soon board the Starship program, turning it into a global effort. In the midterm, the importance of these uncrewed missions cannot be overstated. From a geopolitical perspective, every successful flight helps the US take a decisive lead over China's ambitions. China's Tianwen-3 mission, which aims to return samples from Mars by 2031, is already in development. But if SpaceX can beat that timeline, even by a narrow margin, it would send a powerful signal about American leadership in interplanetary space exploration. This window from 2026 through 2029 is when Starship could truly begin laying the foundation for a sustained presence on Mars. These uncrewed flights will not only demonstrate the vehicle's capacity, but will also be critical for base preparation. Delivering equipment, testing in-situ resource utilization, confirming the availability of water ice, deploying solar power units, and identifying stable landing zones will all be crucial tasks in this period. By the end of this phase, from 2029 to 2031, we may witness one of humanity's most extraordinary milestones, the first human footsteps on Mars. This will mark a seismic shift in exploration as human presence unlocks real-time decision-making, active research, and the beginning of meaningful service operations. This will also be the period when the first true infrastructure takes place. With humans on site, initial habitats will be expanded, power systems will become more reliable, and construction on permanent facilities will begin. From there, Mars will no longer be just a destination for robots or test flights. It'll become a second home. Resources such as oxygen, water, and methane fuel could be produced directly from the Martian environment, building the foundation for a self-sustaining settlement. And while China's sample return mission will still be unfolding during this time, SpaceX could already be achieving far more. With people on the ground supported by Starship's enormous payload capacity, the ability to send research materials or even manufactured goods back to Earth becomes a real possibility. After the short and midterm goals are achieved, the vision shifts to the long term, the construction of a full Martian city. This is where Musk's ambitious vision takes center stage. He believes that in order to build a sustainable, self-sufficient city on Mars, humanity must send at least 1 million tons of cargo to the surface. That scale would support 1 million people capable of surviving independently from Earth. To make this a reality, SpaceX plans to launch fleets of Starships during